Okay, part two. So, part two was going quite badly wrong. It's now a month later. And I had all this horrible stuff about trying to find out which direction the line was going in and which direction it turned in. I got to do the nice thing of deleting most of that. You will notice there is a stolen solution here. Fortunately, I don't understand it. Well, I kind of do. It's hard to read because people don't write Advent of code with the intention of reading it. So I think the two rules we require are lines may not cross and no points may exist strictly in the rectangle. So part one is the same as before. Part two, I've generated lines between each point. So they are in order, but they don't need to be. So then, for each point we are testing, and each opposite point we are testing, check to see if it crosses any of the polygon lines. So this one, for example, from here to here, would cross this line here, so that's out. Also check to see if any points of the polygon are strictly inside, which means not on the line of your rectangle. So if you were to go from here to here, well, no lines cross, and line overlaps are allowed. What we're looking for is strictly different direction crossing, but this point is inside the rectangle, and that's not allowed. So for other points, I've got a function that draws lines. So this is giving me all 4 lines of the rectangle. So let crosses is going to be equal to lines iter any line. Okay. And what I want to make sure is that there are absolutely no crosses between a puzzle line and in fact, I'm going to implement this online. It's going to take a ref self and an other, which is ref capital self, and return a bool. So first off, if they are the same direction, then they cannot cross. So we're not going to count that. So if self is vertical is exactly equal to other is vertical, they must be in the same direction because either they're both vertical or they're both not. They don't cross, so that's good. So now we know that they are not crossing. So if self is vertical for a start, and we'll have an else as well, these might end up being the same. So if self is vertical, we know that the 0 point is the same. So what I want to know is whether or not 0 condition is the same. Vertical is entirely random and arbitrary. I want to check that the minimum value of the 0 of the other line is less than start of 0, and that the maximum value is greater. So if other start 0 min other end 0 is less than, and I want strictly less than self start 0, and so that bit is correct. And so our other line is crossing this one, but we also need to make sure that other's one coordinate, other's y coordinate, is in between. So we know the other's y coordinate, other start 1 is the same as other end dot 1, and you need to be less than or equal to. You need to be less than self start 1 min max. Well, okay, let's do min first. You have to be greater than self start 1 min other start 1. Self end 1. And other end 1. These, okay, it's the same, so that's fine. It needs to be less than self start 1 max self end 1. If that is true, then it crosses and we will return true. And then basically I want the same block again, except that with everything swapped. So now we know that the ones are fixed. So I think I just need to change all the numbers. One, 0, 0, 0, 0, 0, and 0, and false. To do. Thank you. So let's add a test for test crosses. So let's vline 1 is going to be a line, and we'll start at so it's vertical, so the 0 point is not changing. So we'll start at 5, 0, and we'll go down to 5, 10. That H line 2, and horizontal means, so we'll go again from 0 to 10 on 5. Now these need to overlap, which means that the height I want this to be is 5, that's fine. And it's moving from 0 to 10, that should form a decent cross. And assert that V line crosses H line. What don't you like? So the crosses test passed, but we need to do more. So now I want to check 2 lines that don't cross because they are vertical, and well, we can do vertical overlap, and they shouldn't cross. So let V line 2 be a line, and it's going to go from 5 to 5. It could be a single point, that's fine, but actually I'm going to do 10 to 11. And I want to assert that not V line 1 crosses ref V line 2. Okay. Still passing, great. Same for horizontal. Let H line 2 be a line. Start is going to be a point, let's call it 10.5. End is going to be a point that's going to be 11.5. Those should not cross. And H line 1 crosses H line 2. What don't you like? That passes. Great. Now I need to let H line 3 be a line that does not cross the vertical line. So to make this easy, let's just make all the numbers really big. And we need to move in this direction. So not V line 1 crosses H line 3. Okay, still good. And then same for the other one, that V line 3, I probably should have done these the other way around, be some ridiculously long line that moves in this coordinate and assert not H line 1 crosses V line 3. Great. Right, so the crossing algorithm works correctly. So what I want to know is there any puzzle line that crosses that line? Okay. If there is, then we will continue. I'm just going to skip this point. It's not valid. And I'm going to skip this point because I think it's probably easier. Well, it's computationally easier. So now the case we have is this one here, because the rectangle lines don't cross anywhere. Ooh, they do. No, because it's got to be, so that's a test case I should do, where I have a line crossing and a vertical line hanging in the middle. That should not fail. The reason that shouldn't fail is because there could be a point here, and that rectangle would be valid. And I'm pretty sure it's written that way, but let's double check. So let H line, what are we up to, 4? And so this is going to touch V line 1 on the center. So it's going to have a coordinate of 5 there. So that is 5 going down there. So this needs to end on 5, somewhere in the middle. So it needs to end at like 5, 5. And it needs to start, because this is a horizontal line, at some value lower than 5. So 0, 5. X is 0, y is 5, going down. Yeah, okay. This should not cross. Not V line 1 crosses H line 4. Great. And same again for vertical. So this vertical one needs to needs to end at like 5, 5, or start at 5, 5 is fine. And it needs to be vertical, which means it needs to move in that direction. Also to fine, great. Cool. So now I need to check if any point exists inside my rectangle. Check if any point in set exists strictly in the rectangle. And by strictly in the rectangle, that means it does not have. So because it's a rectangle, we can find corners. So we can find the lowest corner in this coordinate system, top left, and the highest corner, which is bottom right. Find lowest corner and highest corner and check. Oh, do I already have this because of the way I've drawn my lines? I don't know, my lines are ordered. Okay. So, I want data iter filter, so each point let lowest point, it's going to be easy to do this, it's going to be equal to a point with point 0 min other point dot 0 and then point dot 1 dot min other point dot 1 and and then highest point is max. And then for each point, I need to make sure that lowest point 0 is strictly less than p dot 0, and p dot 0 is strictly lower than highest point dot 0, and lowest point 1 is strictly less than p dot 1, and p dot 1 is strictly lower than highest point dot 1. So I'm going to look for all of the times that is true, and then any. So actually, I don't even need to filter, I can just any there. And any will end up returning a Boolean. So if any point exists inside, continue again, and then otherwise we calculate the area. Let area be equal to whatever my area calculation is, so it's basically this again. Other point. Okay. That is failing with a value of 40. So get to this point, allowed point point other point. and I will be right back. Okay, so it turns out that whilst this algorithm fails on test data, it does in fact pass the real data. Now obviously I can only know that because I happen to have run someone else's solution, I know what the answer is, and it's kind of luck based on the input data, although a lot of people are abusing the input data. And the reason it's failing on the test is because if you have this point here, so you're comparing that corner to that corner, you don't cross any lines, and there are no points inside the square, inside the rectangle. Another one that's failing is this point up to this point, because whilst this one should be inside the rectangle, at the moment the check is only looking for stuff not on the same line. That one is probably easier to check, which is basically saying I don't want to generate the entire range of sets. So you would say you do this. If p dot 1 is exactly equal to less than p dot 0, exactly equal to the lowest point dot 0, and p dot 0 is exactly equal to highest point dot 0, i.e. we have a vertical line and we're on it, and we have, no, we don't have a vertical line. We have, yes, a vertical line. Vertical is entirely irrelevant, but it's what I'm defining a vertical line as. Then I need to see if p dot 1, then I need to see the, so actually let's make this one condition. So p dot 0 lowest point and lowest point dot 1 is less than p dot 1 and p dot 1 is less than highest point dot 1. So that's saying that if we're in this condition here, where this point exists, no, lowest point dot 0 or that. So if we are on a vertical line, or if we are in the same, if we could be on a vertical line and we are on that line, or the same but the other way round, so these are ones, and these are zeros. I'm going to do some brackets in a moment, so, well, in fact, I'll do brackets now. What do I want to pour? So I think let's stick an and there for a moment just to make it happy. So if you are on the same same x coordinate as either point, i.e. you are somewhere on this line or somewhere on this line, and you exist between these two, oh well, i.e. here, kick you out. or the opposite. So if you exist on this line, or if you exist on this line, kick you out. Or, so that needs to be an or, then we get to this condition, which is you're inside. And for consistency, I'll make that one up. So that should get rid of the biggest one. Did I just run that? Yes, I did. Oops. Oh, that actually made it wrong. Interesting. And it hasn't got rid of the biggest point. So, you know what? Never mind. Let's get rid of all of that. It's fine. It's fine. It's fine. Let's double check I'm back to the correct answer. Yes, that looks 146, ending 144. Yeah, cool. I think maybe I just say this is the answer. The other option to get rid of stuff is to raycast each vertex of the rectangle shapes inside the polygon. So this is a vertex of the rectangle, and if you continue all the way to the left, you will cross an even number, assuming 0 is even, possibly contentious, you'll cross an even number of lines, including vertices, which would need a bit of finagling. And raycasting across vertices fails, except that in this case, because I know it's always a square, then vertices count as part of the line, that's fine. That'd be quite computationally expensive. I've got the right answer. I don't want this video to be too long. It is cheating. I think for now that will do.